All right, so we're gonna go ahead and get started. Good morning, everyone. Thank you for joining today's Research Radar, all about work zone safety, hosted by the Minnesota Department of Transportation and the Minnesota Local Road Research Board. My name is Molly Yang, and I'm excited to introduce our presenters, Stephen Bloffus, Wayne Sandberg, and Michelle Moser. So today's webinar, Research Radar, is sponsored by the MnDOT's Office of Research and Innovation and the Minnesota Local Road Research Board. Each month, we like to highlight different research projects that's focused on a common theme. And so before we dive in, I'd also like to acknowledge that this week is Road Safety Week. And I'd like to recognize the vital role that each of us plays in keeping our work zone safe for our workers, our drivers, and our communities. And today's webinar is an important step for us to strengthen that shared commitment. So again, thank you all for being here. And with that, I'd like to read the Tennyson warning. So this session will be recorded for those who cannot attend. If you have enabled your camera during the session, the recording may include your image, which is private data under the Minnesota Government Data Practices Act. You're not required to allow MnDOT to use your image, and there are no consequences for declining to do so. To opt out of the recording, you may simply turn off your camera. So a little bit about MnDOT's Office of Research and Innovation. We manage over 185 research projects in progress that range from local initiatives to pooled fund projects with other states, comprising both basic and applied research. We're here to help transportation practitioners determine whether new research is needed or if existing studies may solve your needs, recommend the best research methodology for your project, access local and national funding sources, and manage your project from start to finish. Our partner, the Local Road Research Board, is a city and county run organization that sponsors research and educational initiatives that address local transportation needs. You can stay up to date with MnDOT LRB by following us online and subscribing to our newsletters. We'll send you website and subscription links in a follow-up email after today's webinar. If you have an idea for a new project or a problem that needs solving, we are accepting new ideas on Idea Scale through April 1st, 2026. You can scan the QR code on the screen, and this will also be shared out in our follow-up email. And with that being said, I'd now like to introduce our presenters. First up, we have a mobile app to report driver intrusions into work zones with Stephen Bloffus. So Stephen started his career at MnDOT in South Central Minnesota as a field maintenance employee for 9 years, where he gained his firsthand knowledge and passion for traffic control. After that, he spent 3 years in a mobility position for MnDOT in the Office of Maintenance, directing their statewide technology transfer program, which is designed to share low-cost best practices throughout the state. In May of 2016, Steve was awarded his current position of statewide maintenance work zone and operations specialist. His focus is on work zone compliance, involved in the update to MnDOT's maintenance manual and bring new equipment to the state to help improve safety. Among many other various duties, he also serves on a number of committees that are committed to working closely with field personnel for a unified goal of safe work zones. Up next, we have User-Centered Smart Traffic Sign Development Study with Wayne Sandberg. So Wayne is the county engineer for Washington County, Minnesota, where he helps plan and maintain public infrastructure. He's dedicated to serving the community through thoughtful engineering and teamwork. And lastly, we have Michelle Moser with presenting on enhanced safety of highway construction site using low-cost wearable sensor network. Michelle is the state work zone engineer at the Minnesota Department of Transportation. In this position, she provides leadership, technical expertise, and support to MnDOT and its state, local, and vendor partners in managing work zone traffic control operations to meet safety and mobility goals for workers and the traveling public. She has over 25 years of professional engineering experience in a variety of disciplines in both the private and public sectors. And with that, I'll pass it on to Steve to get us started.
Thank you, Molly. Good morning, everybody. My name is Steve Bloffice. I work with MnDOT, the Office of Maintenance. Been with MnDOT for 21 years, and in that time, I've seen quite a few things. And in that, all those experiences, I've learned that anything that I can do to try to help provide a safer work environment for those working in the field is definitely something worthwhile. So today we're going to be talking about the Work Zone Intrusion app. This is a joint project that was put together by both the U of M Human Factors Lab through their engineering department and Minnesota Department of Transportation. And what it does.
Oh, Steve, I think you're muted. Yeah, you just got
Sorry
muted.
about that.
Yeah,
Sorry
there
about
we go.
hit the wrong button. What it does, the app itself, what it does is it offers a easy way to offer a submission of a intrusion within a work zone for field employees at MnDOT. And so, as kind of the challenge based on this screen you see here is the traditional crash data that we have. It only captures those outcomes. But what it doesn't do is it doesn't get into the details as far as, when it comes to the frequency of such things, as far as the consequence events, the near misses, things like that. And then, of course, it also represents the critical safety warnings within the work zones themselves too. So our goal is to transition from more of the paper form, which is a little bit of a challenge for those working in the field, because it would be a matter of trying to replicate that information more than once. And for anybody working in the field, whether you're a supervisor or otherwise, duplication of information is very tedious, and it is something we're trying to combat against. And so this app was one of the ways in which we could try to help mitigate that by just allowing them for a quick, concise way to be able to enter the information, and it automatically populates into our database that we use to track a lot of different safety related items. And we'll go into that a little bit further. So when it comes to the actual safety and data, so it's no surprise that we have a issue when it comes to work zone incidences. And as a note, since 2023, we've had on average about 123 worker deaths within construction sites, and that is a huge problem, something we're trying to combat against. There's a lot of different elements that kind of play into that. But one of the things we try to do, and I'm sure many of you have tried to come up with ways to try to mitigate incidences in where the general public would enter our work zones. And so this is one way that we can try to measure that and get a sense for what are some of the common themes in which those incidences are happening. And by logging that, we can kind of determine whether or not there is an area within maybe a specific layout that is being used, or maybe it's a road type or a time of day, things like that, because we can try to adjust and as far as make some changes to prevent some of those things. There's another element to this too, is that if we do find that there is a problem, the number of occurrences is important as well, because the anecdotal information that we get from field staff saying, yeah, we have intrusions all the time. Well, the issue with that is if we don't have the data and the actual record showing what the circumstances were around that and giving detail as to why, we have very little recourse in which we could use that information, maybe in a much higher level. And I say this is an extreme level, but perhaps legislatively, where we go to the legislators saying, hey, we in the field, not just MnDOT, but we in the field are seeing these issues. This is how many intrusions we have to our work zones, and it's caused by driver inattentiveness, it could be speed, could be a lot of different things. And perhaps that information could be used to help further, develop change in existing laws. So when it comes to the nuts and bolts of the project itself, we wanted something that was a mobile solution, something very simple, and we wanted it to be intuitive. Something that once you open it, you don't need a whole lot of training to understand how to put it in, and as well as the duplication of information point that I was trying to get at earlier is the eSafe integration. eSafe is let's call it the application in which MnDOT uses to track motor vehicle incidences, personal injury, and work zones as well, and a few other things. And so that program is kind of the umbrella in which all of those things are stored within. We can run reports based off of all of those things. And so that is kind of our central location where all that information goes. And the nice thing about this mobile app is once you submit it, all that information gets dumped right into eSafe. And so it's populated all there. We can even make connection between certain circumstances because it's kind of built out in buckets as far as how eSafe has actually functioned. So you got motor vehicle incidences, and then you have intrusions. It works on intrusions, but you can actually connect two records between the two. So you have kind of an understanding that if there was a motor vehicle incident within that intrusion, that information can actually be connected, and you can use that as well. So, and then of course the pattern analysis, which we talked about earlier, is trying to find those countermeasures that we can try to prevent future issues. When it comes to the app itself, streamlined reporting was a very big part of this. And so one of the things we did is we wanted to make sure that when it came to filling out the information, we wanted it to be something that was scalable in a way that, based on the severity of the actual intrusion, it would determine how much information you have to fill out. And so you can notice over on the right is kind of a screenshot of what it looks like as far as the app itself. And so when you answer some of these questions and hit continue, what it does is it determines the severity level, and the next screen dictates based on what you've answered in the first screen. And so if the severity is very, very low, then what can happen is the next screen you go to could just be the submit button. I mean, it actually it kind of it's scalable in a way that it adjusts based on your responses. And so we didn't want everybody to have to go through a long, drawn out questionnaire if there was only certain circumstances that were captured within. And so that was a big part of that. And then also, making a lot of these too, the Human Factors Lab really did a good job as far as querying other people that were not within the realm of transportation, just your average citizen, as far as how these, whether or not to use like buttons or radio button or checklist or drop downs. And we found that the radio button is definitely or checklist is definitely one of the best as far as fast, because you can really dial in what you want and get to the next screen and move along very quickly. So the comparison from what we were using was the paper and or web form. And so the paper form itself, you can kind of see as an example of these two images. The one on the left is our old paper form. This is what we used to have. We used to offer this to field maintenance staff, and they would fill it in based on the situation. And then what would happen is when they got back to their computer at the end of the day, then they would have to re-enter this information based on the paper form into eSafe. And so now with the new work zone intrusion reporting, we're able to do that direct, and we don't have to duplicate that information. So much faster. As far as what we get out of the information, we do have some insights. This is just a few examples of some of the data that we get. And so when it comes to different types of intrusions, figuring out what day of the week perhaps is when it happens most. In this, the bar graph shows Thursday is probably the highest risk day. And so in this case, you can use that information, or at least the supervisors can, to determine maybe Thursdays are the days that I dedicated work for the work zones that maybe are off of the right of way. Maybe they're doing some ditch work or some tree work, things like that. And so it can help them in that regard. As far as the intrusion types, this also kind of gives you some insight too, as far as what is the circumstance in which the intrusion actually occurred. And so in this, you can see that you've got an other, which other is more of an all-encompassing, where there wasn't any one thing that really was defined as to what the intrusion was. But then in other cases, you've got they disobeyed the flagger, they failed to move into the correct lane, things like that. And so it actually is very useful to have this kind of information too. As far as the consequences intervention, so one of the reporting aspects that we offer, and we try to do this on a quarterly basis. In fact, I'm working on developing a reporting mechanism within Power BI, which is a app that Microsoft develops. It has developed, and what it's going to do is it will connect. Hopefully, it will connect with the database and be able to automatically create this type of reporting. And it's done in a graphical manner, so you can kind of get a sense for what it looks like. But in this, you can see types of incidents that are reported. So a failure to move into the correct lane, that was the highest. And then for safety equipment also too, it kind of gives a sense too as to what kind of equipment was being used in the event that the intrusion occurred. And so with that, we might be able to decipher as far as how we can move away from some of that stuff and improve on that. And then, of course, consequences. One of the things we advocate for in the field too is that there is an intrusion. Reporting it is a big part of that. But like if a flagger was disobeyed, so if somebody didn't listen to a flagger and blew through, we actually have state legislation to go after those that do violate that. And so that is very useful. And in discussion we've had with State Patrol, they've been very helpful and supportive of that effort. And so anytime we call them, they follow through with it and make sure that people get an educated moment, let's call it that. As far as the actual conclusion of the app itself, it has been successful. We've had some very good luck with it. We haven't had a lot of use out of it. That's been a little bit of a try to get field maintenance staff to use, and a lot of times, their reasoning behind it is, I'm out there doing the job. I don't have a lot of time to be able to, stop what I'm doing to be able to enter this information. And one of the things we did is we determined who would be best set to be able to create these reports. And so we started out with what we call TOS 2s, TOS 1s, and TGSs, which they're kind of a supervisory level, some more than others. A TOS 2, they're probably the higher within the field maintenance, and we gave them the tools to be able to do this. And the reason why we did that is because MnDOT, we have a state phone policy, and or I should say a phone policy, and so it prevents them from using their personal phones during state work time. And so that's what we focused on, the TOS 2s, TOS 1s, and TGSs, because they have state issued phones. And the nice thing about the app is they can download it direct from the Apple Store and utilize it. There is a login, and that login is the same that they would use to be able to log into their computer, and be able to enter the reports in themselves too. So, and then of course we've got when it comes to the focus areas, policy review is a big part of that too. It's identifying the information that we gather and determine how we can best make change to be able to help those in the field. Enforcement targeting too. We, based on road type, ADT, all those things, we can actually work with State Patrol also to get them in and provide some enforcement on those in those specific areas. So, and then of course you've got the long-term monitoring too, as far as data trends, things like that. And we do have other plans moving forward. And I'm going to leave that for the question and answer because I'm coming up on my 15 minutes, and I just wanted to let you know that we do have plans moving forward with this. A small change, but the base information as far as what we've gathered from here, we're going to utilize that moving forward. So. All right, we'll leave the questions and discussions, I think, until the very end, if that's all right. And so I want to say thank you for all for joining, and I'm here to offer any information you might have. Thank you.
All right, thanks, Steve. Well, again, yep, questions answered at the end, and we'll move on to Wayne.
All right. Thanks, Molly. Good morning, everyone. As was stated earlier, my name is Wayne Sandberg. I serve at Washington County, Minnesota, and today I have the honor to present a study that we had done funded through the Local Road Research Board. This study was really to try to evaluate, kind of answer the question, can we use an audible warning to influence driver behavior as they approach a work zone, especially focused on improving flagger safety in these unpredictable and high-risk work zone. And the second question that we wanted to answer was, can we make such a device portable and lightweight and also reliable? I do want to recognize the engineering team led by Rajamani, Helen Rose Jorgensen, and Isan Kazemi. I'm presenting the material, but they did all the heavy lifting. And also want to throw a shout out to Nicole Morris, U of M, and David Glyer at MnDOT for being key parts of the team here. So as we know, flaggers face real risks from speeding and distracted drivers. Like I said, our goal was to develop a lightweight, field-ready system that can detect potential intrusions and alert both workers and the driver, giving everyone more time to react. And the idea behind alerting the driver was to use a loud, audible tone that they could hear inside the vehicle that would kind of wake them up to what was happening and hopefully cause them to decelerate and slow down. So this slide shows our first prototype on the left, developed during phase 1. It featured a stationary stop sign with a scanning laser, video camera, speaker, and all the electronics were in the base. And while it was technically functional, it lacked mobility and visibility, especially in work zones, the dynamic area of the work zone. It just didn't stand out enough. Also, after gathering user feedback, we decided to pivot toward a more intuitive design using a mobile traffic light system with more of a clear message, stop here on red. This version actually improved driver compliance, but still wasn't where we needed to be as far as portability and affordability. So in phase 2, we built a more rugged device based on simulator study outcomes. This version included a radar, camera, and a speaker mounted on a wheeled box with a dual telescoping pole system. So the sign could rotate between stop and slow modes, and the upper pole was removable for transport. However, this unit was too heavy and too cumbersome for frequent lifting and moving in work zones, and really was moving away from our initial mission. We weren't trying to create an auto flagger. We got some good feedback and some testing, and it pushed us to rethink the portability aspect and the ease of setup, and led to what we call the Gen 3 prototype. So the third generation prototype is much smaller. It's housed in a waterproof toolbox. The stop slow sign is no longer connected to the device. This has now become a standalone device. That was a critical change because it allows us to place the device upstream of the work zone, away from the flagger, but ahead of the flagger position. It also could allow us to use more than one device to be placed in the work zone. So you could potentially have multiple of these to increase reliability and connection to the driver. And we found that the portability also gives drivers a better warning, but it was easier for the workers to manage. So it weighed just 16.5 pounds. The unit collapses for transport, expands for operation with a telescoping pole that raises the radar. It has locking brackets for stability and LED indicator to confirm that the system was active and recording. Setup we found was fairly simple and straightforward. It was easy for people to do without a lot of instruction. They place the unit on the ground, extend those leg brackets, extend the pole, align with the lane, and press the power button. There was no need to get into the electronics or open the case unless there was a battery issue. But inside the case, you want to see inside, it included a removable battery. The brain of the system is a Raspberry Pi, a pretty much off-the-shelf product. Some other details in there, the wave trigger board, the amplifier, and power splitter. The radar sensor was also an off-the-shelf product at Texas Instruments AWR 1843. So overall, the system was pretty compact and reliable and also very affordable. That radar system was less than $500. So total all in is right around that $500 mark, $500 to $600. So we conducted 6 field tests across rural, urban, and suburban sites. In 4 tests, we left the alarms off just to evaluate the vehicle tracking features capability of the device. Then in 2 tests, we added the alarms to actually activate to see how drivers would respond to it. I'm not going to go through all the sites, but I'll give you some examples. So the first one, the urban site, allowed us to test intrusion and detection in active traffic. And the system was evaluated for accuracy and alert timing under some real world conditions here. So what we did was we placed devices 5 meters downstream and 50 meters upstream from the flagger. Again, the alarms are off here just to focus on vehicle tracking and reliability. Over 2 hours, we tracked 481 vehicles. 6 were identified as violators, meaning that they were coming in too high of a speed or weren't decelerating where we thought they needed to be to really slow down appropriately. And so about 1.25% demonstrating this is an ability to, it really was able to detect unsafe behavior. We tested different deceleration curves to try to determine when a warning should trigger. You don't want to overwarn drivers who intend to stop, but you also don't want to miss drivers that need that warning. So we really looked hard at various deceleration curves and plotted where vehicles are coming in these real world tests. And we came up with a 0.175 G threshold, which means 0.175 G, the rate of deceleration. So at 9.81 meters per second, 0.175 would be a 1.72 meters per second square deceleration. And we determined that that would be the appropriate line to, if they were above that, they would get a warning. So the suburban site offered a different environment. Both devices had the alarms on here, and then we wanted to test both the reliability and the effectiveness now of that sound on driver behavior. So we did the device upstream. Initially, it was issuing a lot of too many warnings, so we had to tweak that. The downstream device was only activated in stop mode. So the posted speed limit also dropped just before this work zone from 35 to 30. We think in hindsight that maybe influenced the driver's speed coming into the work zone, that they weren't behaving illegally, but they were going faster than the system was expecting. And so that may have influenced some of this test. But with that said, we still thought we had great reliability. In 1.5 hours, we tracked 66 vehicles, not a super busy work zone. 11 received upstream warnings, and of those, 5 also triggered downstream alerts. 4 others only triggered the downstream warning. This chart, this chart kind of graphs the velocity curves coming in. It's a little bit messy, but we analyzed the trajectory of those 11 violators. Most drivers began braking within 1.5 to 4 seconds of receiving that audible warning. So we think that showed that they did hear it, and it did cause them to change their behavior. On this graph, you can kind of see the star markers show when the warnings were issued. With driver reaction time, is a bit of a delay from when we issued the warning until when you see the curve drop down. A notable one is that brown curve on the left side. You can see we gave the warning, and then you start to see driver behavior drop after a few seconds after. So the curve, we think the curves reflect that drivers who did receive warnings did react and did slow down. Of the 11 violators, 6 slowed after the upstream alert, 5 required that second warning, and 4 of those stopped completely. So in total, 10 of 11 vehicles did come to a full stop before they reached the flagger. The system actually records video of what it's seeing and can record violations. I don't have the video to share here online, but it is very accurate, very robust. It can detect not only vehicle location, but deceleration of the vehicle. So the actual technology was very robust and very reliable. So across all 6 tests, we were able to track every vehicle. We didn't miss any vehicles when it comes to tracking, which is important for reliability and trust in the system. Later tests added more mode-specific warning curves and audio-visual alerts. In Eden Prairie, no violators were detected. In Mound, 10 of 11 violators stopped. So we thought that was also validating in the fact that we weren't over-warning people that didn't need to be warned. So that really is the summary of the test. That's where we've left off. It is still in a prototype mode. We have not moved to the next step. I want to thank everyone again for their attention today, and just generally wrap up. Across those 6 field tests, Gen 3 prototype worked reliably. It tracked every vehicle. We did not miss any detections. Those mode-specific alerts and upstream placement did give drivers more time to respond. So decoupling this from the sign itself was a good move and allowed us to add more units to the work zone. And then, like I said, in our final test, 10 out of the 11 violators did come to a full stop before reaching the flagger. So we took that as also evidence that the system worked. And I think what we showed and proved here, our initial question was that, yes, an audible warning system coupled with some visual cues can influence driver behavior. That audible warning can be heard inside the vehicle. It's loud. It's about 110 decibel warning. We also learned that portability was really important. So generally, we think we proved what we set out to prove, and that the next step would be to take some more studies and see if this could become more of a marketable product. So with that, I'm happy to turn it back over to Molly.
Awesome. Thank you so much, Wayne. And up next, we'll have Michelle. Go right ahead.
Alrighty. Someone here in Teams. Okay, so as Molly said, I'm Michelle Moser from the Office of Traffic Engineering. I'm the State Work Zone Engineer. And I will be presenting today on our project Enhanced Safety of Highway Construction Sites using a low-cost wearable sensor network. All right, so first up, why does this matter? Well, highway work zones are dangerous places, both for the traveling public and for workers, as there's a lot of changing conditions, things happening, a lot of things to be distracted by for drivers, and then those distractions can sometimes prove very dangerous for our workers. So there generally is over 800 fatalities and about 40,000 injuries annually in the US in work zones. Those aren't all workers, thank goodness, but they are drivers and workers across the board. So there's room for improvement on this. Workers are at risk from both nearby equipment, as we've seen in recent incidents in Minnesota, and from passing vehicles too. So our goal was to use affordable, wearable technology to prevent crashes and save lives. So the system design was a safety sensor system that includes a wearable alert device for workers, sensors on construction equipment, and intrusion detection on traffic cones or other delineators, and then a cloud-based dashboard for supervisors or others in the office to use to monitor or look at data after the fact. You'll see on the graphic here that that's sort of kind of a graphic on how this system works. So you'll see kind of the mesh network, which kind of makes up that network of sensors that you have around your work site on workers, equipment, etc. Those are all kind of talking to each other and then also transmitting to a gateway device that transmits to the cloud and then back into the central kind of dashboard. So workers and equipment have GPS-enabled devices on them. Those devices talk to each other through that wireless mesh network. And then if a worker gets too close to equipment or a vehicle enters the zone, that worker will get a vibration and a sound alert. And then also anyone in the office who is real-time monitoring it can see that on their web dashboard. And they can also gather that data afterwards on how many potential incidents there were that happened in that work zone. So again, a graphic here kind of shows that network in a work zone layout. So delineators with devices on them, equipment and workers with devices kind of form that network around that zone. And it can detect that vehicle entering through that barrier made by those delineator devices and then within the work zone between workers and equipment. So key features of this system, a key feature was for sure to make it low cost so that it's affordable and scalable for many work zones. These devices that you'll see here on the right, the prototypes, have different modules in them, the ability to add modules for toxic gas sensing and different things like that in the future. Um, Also to get real-time alerts, so to get as close to immediate warning as possible to make sure that there's reaction time and we can prevent those crashes or incidents from happening. Accurate tracking, so combining GPS and motion sensors and making sure that we have high signal strength to give us more accuracy. And then having that cloud dashboard to be able to monitor incidents either in real time or review them afterwards or at the end of the day to kind of take in some of that data on how much or how many intrusions and different incidents are happening. So testing the system, there was both lab testing, which checked for comfort and alert clarity, device placement, those types of things. And then there was also some real world field testing. So um, we had some great MnDOT crews volunteer and agree to work with these devices and do some real world trials while they were working. And the system was able to detect hazards accurately and reliably in that field testing. We also gathered worker feedback. So workers said this was comfortable to wear, the alerts were clear and helpful, and that they would trust it on a real job. They did have some suggestions to make those alerts louder, vibrations stronger. If anybody's been in a work zone, it's just a really active, loud environment. And there's a lot of noise, there's a lot of beeping, there's a lot of different alerts going on. So you can become kind of complacent and tune those out because they're just kind of part of that everyday work. So having something different, louder, stronger, to make sure that they recognize those alerts is important. Results of the testing, so there were 0 false alarms in the field tests, and there was over 90% accuracy in detecting real hazards. Um, this will help prevent accidents before they happen, and they felt that it would reduce paperwork with the automatic incident logging. So next steps on this project, there is a broader testing need in more work zones. These work zones that we tested it in were fairly low traffic, not a lot of high-speed traffic, not super active work zones. So we are looking to do a phase 2 project in some more active work zones, high-speed traffic, and be able to kind of create a real network with more equipment, more workers and devices. And to improve that alert hardware, so again, making louder, stronger alerts for the workers. We also need to determine device manufacturing options. So right now these are being 3D printed in a lab, and obviously that's not really a viable option going forward. So looking for some manufacturing options or potentially a vendor that is willing to take this on and carry it forward into the market. And then, of course, training and deployment. So training workers on the devices, making sure they work with all of our equipment, and then deploying them, working with the dashboard to see what kind of data we can get. These are all things that we need to do to continue this project. And then I wanted to kind of circle this all back to our mission and vision at MnDOT. So this really supports MnDOT's goals in safety, safety first, safety always. Anytime that we can do something that will hopefully lead to fewer injuries and fatalities just across the board, not only in work zones, that's a key thing that we look to working towards. Innovation, of course, so using smart, modern tools, trying to make sure that we are connecting more devices and being able to use technology to our benefit is something we're always looking towards too. And then efficiency, less paperwork and better data. We're always gathering data that can inform us on how we can improve our operations and making things more hands-off, less paperwork for people to do, and just kind of more automatic tracking and gathering of data are really important too. Some final acknowledgements. So NDSU was our principal investigator for the project. Yujin Zhang and her team are doing a great job. At MnDOT, Barb Fraley, our research services liaison, and then Steve, who spoke on the first project, is also on this project and has been great with many comments. He's very techie, unlike me, so he's had great comments and made great improvements to the system, along with connecting us with maintenance. Joe Brewer from construction and others who had input, and then our MnDOT maintenance crews who are always willing to help us when we've got these things to test out. They've been great. All right, so thank you. That's the end of my presentation. I think we'll be ready for questions and comments now.
Yes, we are. Thank you, Michelle. And again, thank you to Wayne and Steve as well. So I think after today's webinar, there's a lot of things being done to help improve safety in work zones. And with that, yeah, I did see a couple questions in the chat, which I'll read it aloud for the entire group to hear. If anyone has a question that they would like to ask, I will allow mics for all attendees, so you can also raise your hand and ask questions that way. And with that, I believe our first question is for Steve from Rob. Do you have plans to open this up to contractors to use? I would love for all my crews to have this tool, referring to the app.
That is a great question, Rob. Actually, so that discussion has taken place, and so I'm going to hit on what our plans are for this that might help improve that functionality beyond just MnDOT employees. There could be also contractor contractors that are hired to do state jobs as well. And so in that process, one of the challenges we've had with the app, unfortunately, is because it's Apple based. The API that's being used to be able to capture the data and move it forward. Anytime Apple has an update to an iPhone, that API could potentially be broken. And then, unfortunately, MnDOT ourselves, we don't have anybody that is designated to do the mobile app developing part of that, which is why U of M was part of that and they created it. And so anytime we have to do an update to that, we have to go back to them and do a new contract, things like that. And so one of the things that we're going to move forward with is we're actually looking to create a web app, which is not an app specific as far as per device. It'd be more of like you go onto a website, but yet it is let's just say it can be adjusted to look like an app on a phone to be able to enter that information. So there is more to come, Rob, as far as whether or not contractors will be involved. That discussion is being taken place right now. So I can't say indefinitely, but if there is, generally speaking, I would imagine it would be something that would be specific to those that work on state projects.
Thank you, Steve. Yeah. All right, going on to our next question. I believe this is for Wayne, from Robert. Are the devices linked to the flagger paddle, and what is the operating range between flagger and device?
Yeah, thanks for the question. At first, the first few prototypes, the device and the paddle, the flagger unit was all one, and they were linked. When we decoupled to the portable device, we deconnected. So the flagger paddle was just a standard paddle, not a smart paddle. But the devices were set up to, as you come into the work zone, far out and then closer. So we're 60 meters out and then 5 meters out. That's roughly the range that we had for this product. I think if we decided we wanted to increase those ranges, there could be adjustments to the technology to allow longer ranges. But then you'd also be looking at different deceleration curves too, as to when it would give warnings.
Hey, thanks, Wayne. I guess part of my question was I thought your presentation said the device knew when it was showing stop or slow, and that's what prompted me to ask that question. So how would it know unless it was either visually seeing it or was connected? So.
Yeah, I think that might have been referencing some of the earlier prototypes. I think there probably is room to, as we looked at maybe the next phase of this, maybe you could create a scenario where it would know more about what is being displayed by the flagger itself.
Thank
Thanks.
you. And with that, this one is from Steve, also for you, Wayne. And Steve, feel free to chip in. Is the system able to differentiate if the vehicle is in the lane that is being occupied versus adjacent open lanes? And how well does that work around curves?
It's a great question. Yeah, yes, we are able to tell if it's in the lane. I didn't have the video, but the video detection was pretty robust, and it could actually pick up a series of vehicles that were sequentially coming in. It could really tell at pretty good reliability of the number of vehicles coming in, platoon. I don't think we tested it as with a multiple lane. That might be a good next step. And we actually didn't do a lot of curve testing either. It has to be within line of sight. And so that would probably be your limitation on a curve, but all those could be good future phases.
Thank you, Wayne.
All right, our next question is from Carolyn, also for you, Wayne. Was there any feedback from neighborhood residents about volume of audible warning when running tests?
That's another great question. The sound, I wish I would have had the audio file. It is loud. It's a relatively higher pitch sound. And I would expect that there could be applications where residents might wonder what that sound is. But we did not include that in any of our feedback loops. So I don't have data on if that was being heard by neighbors or in what they might have thought about that. But that's a great, maybe a next phase too, to look at. Is that causing other unintended consequences with neighbors and others?
Thanks, Wayne. And I see here we have one from Bruce, which I believe this one is for Michelle. Has MnDOT collected any outcome data comparing asymmetric with symmetric zipper merging instructions?
So I'm not completely sure what Bruce is asking about, so feel free to, I think, unmute if you want here. But if you are talking about having sort of a symmetrical funnel type layout versus the kind of asymmetric going into a right lane or a left lane zipper merge, MnDOT hasn't really tested that out. It is thought that that will potentially lead to more kind of racing type of behavior than we would maybe already have. We also are kind of tied to the manual on uniform traffic control devices with our zipper merge, or the technical term for it is late merge. And there's a layout in the MUTCD on the late merge and the signing that's associated with it. So we are also tied to some standards there to make sure that it's applied uniformly across the country so that people can understand it no matter where they go. So, I don't think there's been a lot of research done on that funnel type layout, just because it is not a standard late merging layout. There has been some research done on signage and advanced signage recently, so we will be looking at that as we update our zipper merge layout and signing to comply with the new version of the MUTCD, which will be adopted in January. And there is some new regulatory signage associated with zipper merge or late merge that we need to add. So hopefully we'll see a little bit better compliance. We do try to educate every year, and we do get a lot of questions on the zipper merge at the beginning of each construction season. So we're just kind of trying to continually educate people on the benefits and how to use it, and hopefully they'll catch on here.
So thanks, Michelle. And I see here we have one from Chris for all three. Chris says, on all three items, which I see to be very useful to reduce incidents, have they been benchmarking to other states looking or using similar items?
If you'd like, Molly, I can start on that.
Yep.
So, Chris, that is a great question. Right now, I am not aware of any kind of incident reporting such as what we've developed here. And I can say that with some certainty because Minnesota is one of the states that is involved in a multi-state effort called the Midwest Roundtable. And we've brought this to their attention, and a lot of them have interest in this as well. And that kind of piggybacked on what Rob had asked too, as far as whether or not other contractors could use this, things like that. There could be a potential for a pooled funds project, perhaps, where we could actually develop something that is utilized more centrally and not just at MnDOT, and then try to offer that to other people rather than just state employees.
I can go next. I'm not aware of a national review on this device. This device actually started, the inspiration for this audible warning came from a device that the University of Minnesota was testing on bicycles. The idea was that if a vehicle gets too close or encroaches into a bicycle zone, there'd be an audible warning to warn the driver that there's a bicycle somewhere around the vehicle. And so that's where we got the inspiration to try this in a work zone. But I'm not aware of others nationally looking at this type of approach.
Yeah, and for the work zone sensor, there are some devices in the market, various devices that are proximity sensors or specifically work zone intrusion sensors, but nothing that I guess creates kind of that network that can do multiple things. and kind of equipment workers and the intrusion portion kind of all talking to each other and creating that network around the work zone. So that was kind of the point of this project. Some of the other intrusion devices, things like that out there, can be really affected by weather. There's kind of, tubes that go across the road that can be moved by traffic, that kind of thing. So this was really an effort to try to make a sensor that's not affected by the surrounding weather conditions, traffic conditions, and then everything can talk to each other to kind of accomplish a full kind of safety network around a work zone. So there's pieces and parts, but this will be maybe the first of its kind in a network fashion.
Yeah, thanks, Michelle. And I guess to kind of pick off Chris's question, I know, Michelle, you mentioned that those wearable sensors are connected to like this dashboard, right? Where you're able to kind of look at alerts and like where driver intrusions are happening. And I also like to extend this to Steve and Wayne. Could there be a possibility of having, like a unified dashboard where you can track trends and track analytics? Like this is an area where a lot of intrusions are happening, or this is an area where drivers are not slowing down. What would that look like, and is that a possibility future?
It feels like, from what I've learned from the University of Minnesota's team, is that with technology, almost anything is possible. And I love the idea of getting creative and linking these things together to protect our workers. I think you mentioned, Molly, at the beginning, the LRB is always looking for research ideas. And so this is the kind of stuff that if people have these ideas that pop in their head, please send them to the local road research board. We love getting these kind of ideas.
One thing I'd like to add to Molly is, the connection of these and say a multi-state, and not just within our state, because, in-state is a little bit easier. But if you're talking about involving multiple states to be able to do things like this and track incidences, one of the challenges there too is having a unified way of being able to do any kind of measurement, because many of our layouts that we have within Minnesota, although layouts are generally similar throughout the state, they're not exactly the same. And so it'd be difficult to be able to do that unless perhaps you built in some type of a filter to only show the incidences of the I guess the organization that is actually creating the information, and utilize that for their needs. And Michelle could probably jump in on that. I'm sure she probably feels similar.
Yeah. We're always looking for ways to connect more devices to drivers and to workers. So um, generally, when I'm on a research project or we're looking at connection, and I know on this sensor project, I did ask about connecting it to our intrusion app so it could maybe directly report these things and people wouldn't have to report them in the intrusion app, that kind of thing. So those are things that we always look at, and that wasn't a top priority in this first phase of the project, but it definitely would be one of the priorities as we improve this device looking forward. And then just as we research devices and develop devices, again, always looking to connect things, make things more automated, be able to make them uniform with other devices that we may use, potentially be able to connect them to things like Waze, which some of our other work zone devices speak to. And that connection then benefits everybody, including the drivers, and gives everybody more information on what's going on as they navigate around work zones. So we that's a top question that we always ask in these projects, and it definitely, as we move forward and technology gets better, it's definitely something that we look at in every one of these projects, is how can we connect this and make sure that it's uniform and can connect with the work zone data exchange, which is that based kind of network that is connecting and speaking the same language in all types of electronic work zone devices.
Mhm. Yeah, yeah. And I think all the work that you all are doing is extremely crucial, and it's just curious, like there is potential for cross collaboration there. Um, and I did see we had another question come into our chat from from Kyle. Um, how can departments like materials and soils drilling crews be included on these tests and or help with suggestions? We have 6 drilling crews in the state. We are working on centerline projects, often all over our district, and we use truck stations for traffic control. They also use auto flaggers a few weeks ago with success, but a handful of intrusions. The drillers in District 6 use the Guardian Angel clip on LED lights, on our vests, on projects. And then just general great info and testing devices. Very interesting.
I can maybe share when it comes to local research board. We're always open to and excited when different work groups are interested in helping us test. In fact, with this particular one that I was involved with, we actually had a hard time finding locations to test. Kind of align our work with the crews that were out there and when we would have work zones that we could set up. So I would say, continue to try to connect with the local road research board about your availability and interest in being a testing group. And then as these opportunities pop up, we can reach out.
Yeah, within MnDOT, I would say we are always looking for our internal crews to help us out with testing. It's kind of the easiest way. Aside, getting it on construction projects is not really easy when they're kind of already under contract, etc. So maintenance crews are easiest way, and we get great feedback from you. So at MnDOT, if you're interested in helping with something, I would say let Steve, he's in the Office of Maintenance, know, or me, either of us. Generally, if it's a work zone device, one or both of us is the project, and then we can kind of note that for the project. We also, I think, are always looking for people with boots on the ground to be on our technical advisory panels. So if you have time to do that, it's not a huge time commitment. And again, express interest to us or to Office of Research Services in being on a technical advisory panel. And I'm sure any of us can connect you to these projects that are happening.
And I've already answered Kyle's question regarding the intrusion app. So
Yes, thank you guys. I appreciate that.
Awesome. Yeah. And I guess something that I've noticed is, a lot of these devices and technologies are very much within our internal processes. And I'm curious to know, are there any efforts being done to reach out to external stakeholders, like to our community, to our residents? Because, safety is a shared effort and a shared commitment. So while we are trying to do our best to protect workers, are there other ways that we can reach out to either neighborhoods where, hey, we're going to be installing this audio visual tool, and like here's why it's important. It might have unintended consequences of maybe being too loud, but while we're working on that, this is an effort that we're trying to make to ensure worker safety. So I'm curious, are there any external efforts that you guys are thinking about, potentially the next phases of your projects?
I can maybe start with the local research board one, not specifically tied to this study. We don't have a next phase planned. I think we're open to feedback on that. But I do think, Molly, you're hitting on a really important component of the communication of the work that we do. Like, for example, at Washington County, we are heavily using social media to let neighborhoods and residents know when we have lane shifts, closures, detours. And so that might be a whole other presentation we have to talk about at some time in the future.
Yeah.
I can jump into Molly. As far as next steps for us, it would be the development of a web app that functions a lot like an application, only, even through a browser, you can get to it. And you know, the idea of that too is we want it to be something that is that adjusts based on your screen size, so it actually looks and has a very similar feel to the app itself. And then of course, as I mentioned in my presentation, the automated type reporting aspect too, to develop you know, reports that somebody can take a quick look at and get an idea as to where some of those problem areas lie. Those are two big items that we're going to try to move forward with on. And of course, you know, Rob's given me some ideas about, you know, as far as moving forward with this on more of a maybe if it's not regional or national level, that's a that's a large effort, but it is something that I do have some interest in. So.
Right, yeah, and for the intrusion sensor project, that one we have not really worked too much on communications externally. I think really in terms of intrusions and that kind of thing, just work zone communications in general, we really should cover that. And I think at MnDOT we do try to make sure that we are communicating work zones through websites, through social media. I'm not a huge social media user, but I do think that we could probably increase our social media presence out there at MnDOT. So hopefully we'll be able to do that in the future. In our office, we do work with the communications office on kind of determining what ways we can communicate on different things like the zipper merge, communicate for education, communicate just for informational purposes. And then of course we have things like the 511 app that's continually being improved for communicating for navigational purposes and things like that. So we are continually trying to work on communicating to the public what we're doing in work zones and then just kind of what we're doing in general. And I think, Molly, you said this is a public webinar. So I think things like this too, that if we can get that out to the public and they can listen in on some of the things that we're doing, then, we can get some more feedback and we can educate them a little bit more on what we're trying to do in the work zone space and in other spaces.
Yeah, for sure. Thank you. Thank you all. All right. Any last questions? We do have a few minutes left, so feel free to drop them down the chat or raise your hand if needed. Let's see. Just want to make sure I didn't miss anyone. Okay. Well, then, I think that is all for our Q&A session. If there are no additional questions, again, thank you all for joining and attending our Work Zone Safety webinar. This is, a step towards making sure that we are all collectively keeping workers and drivers and people in our community safe. Thank you to Steve, Wayne, and Michelle for presenting on all the important work that you're doing. And with that being said, there'll be a follow-up email with a recording of today's webinar, as well as resources to today's projects. And if you have ideas for a potential research project in the future, we'll also share that link for you to upload your ideas. So I'll give you 5 minutes of your time back. Thank you, everyone.